recording also.
We'll start once the strength comes. 4, 5.
ನಮ್ಮ ಇವರು ನಿರ್ಮಿತಿ ಕೇಂದ್ರ ಅವರೆಲ್ಲ ಜಾಯಿನ್ ಆಗ್ತಾರೆ ಅನ್ಸುತ್ತೆ.
ಎಲ್ಲ ಸೈಕಲ್ ಇದೆ ಸರ್. ಆಕ್ಚುಲಿ ಅವರೆಲ್ಲ ಸೈಟ್ ಬಿಟ್ಟು ಬರ್ಬೇಕು ಈಗ. ಪ್ರಾಜೆಕ್ಟ್ ಡೈರೆಕ್ಟರ್ಸ್ ಅವರು ನಿರ್ಮಿತಿ ಕೇಂದ್ರದವರು. ನಮ್ಮ ಡೈರೆಕ್ಟರ್ ಮೆಸೇಜ್ ಆಗಿದೆ. ಗೌರ್ಮೆಂಟ್ ಗೊತ್ತಲ್ಲ ಸರ್, ನಂಬರ್ ಆಫ್ ಎಂಪ್ಲಾಯೀಸ್ ಆರ್ ವೆರಿ ಲೆಸ್ ಇನ್ ಎವರಿ ಫೀಲ್ಡ್.
ಅದರಲ್ಲೂ ಅವ್ರದ್ದು ತುಂಬಾ ಫೀಲ್ಡ್ ಸ್ಟಡೀಸ್ ಜಾಸ್ತಿ.
ವೆಲ್ಕಮ್ ಡಾಕ್ಟರ್ ರಮಾದೇವಿ ಫ್ರಮ್ ಕುಮಾರಗುರು ಕಾಲೇಜ್ ಸರ್. ಶಿ ವಾಸ್ ಮೈ PhD student. Now she is a professor and heading the lab what we have set up from back. Ramadevi.
Nice.
Dr. Ramadevi.
I think she is still connecting.
Okay. Now she is taking care of the centers of what we developed, the Structural Technology Center. It has inaugurated in 2003. CSV sir came for that program.
Nice. Yeah.
Actually, he stayed 3 days and we inaugurated on that day with the governor. Now she is in charge of that center, sir. Actually, they are going for NABL also.
Nice.
So the NABL also, there is a number 1 Coimbatore.
Nowadays, most of the more and more institutes are getting this NABL accreditation in the laboratory.
Because one of the guidelines for NAC and NBA.
It's very good. Actually, all the laboratories, they get updated in terms of calibration, system, procedures, operating procedures, and all that. So NABL is always good. And traceability. So many good things are there.
Yes, sir. At least they will, the teachers will know and the students will be benefited finally labs.
Correct. No, and also it will help the industry because nowadays they say that anything you want to get it, you can get it tested in engineering colleges. Credibility of the engineering college goes up.
2003, I set up the lab with high-tech stress strain, even everything automated, completely automated steel test. 40 mm rod also we tested at those periods. 2003. No one in Coimbatore at that time. I don't know. Even we tested the centering pole, steel centering props, and all the cement and concrete we are giving in 48 hours results.
Actually, if you have to test 40 mm rod, your universal testing machine should be at least 120 ton capacity.
Yes, sir.
Yeah.
And CMT training, there are 20 members are coming, so all be possible only. Because
actually your institute can look into having some finishing courses, developing the finishing courses. You can make the students employable to the industry.
Employability.
Most of the time, people who are in the industry, they say that the fresh graduates who come out of the college,
they are not fit to
be employable as such.
Yes, that is one of the objective of the center also. Employability skills, vocational skills different. Employability skills. Another 3 types of skills we have to impart. Actually, this is only upskilling just to impart some knowledge. What is the technology? What is the material available in the market? Because the Nirmiti Kendra engineers are restricted their activities in the district level and taluk levels. Actually.
Correct. Yeah. Sir, if you have programs for the students, it will be really helpful.
Yes, sir.
As a finishing program.
Yes, sir. We will have one directly as one of the type program with your STEDRANT also we can do, sir. Let me know what are the programs we can jointly. It is finally the government is a non-profit organization, but they will give the funds.
Yeah.
8th, I am attending a 3rd EC meetings actually. I proposed some 7 courses in that. Advanced plumbing system, welding systems, and also GIS remote sensing. and painting. With respect to civil, I am taking care, sir. Mechanical, there may be another person with respect to automation, robotics, and welding. And electrical and electronics already finalized.
Good.
Hey, good evening to one and all present. Sanath, you are available?
Yes, sir. Please start,
Please
sir.
admit the numbers who are all coming.
Okay, sir. Okay.
Yeah. Good evening to one and all present. Here, I am happy and honored to welcome all the participants and also today the speaker of the day, MS Sudarashan, Managing Director, STEDRANT Techno Limited, today with us to share some of his experience and expertise with respect to non-destructive testing of concrete structures. See, this is the 52 last series of lecture. See, we have planned for upskilling program for construction management and engineering economics for the Nirmiti Kendra engineers as a master's trainers training program, and it has been scheduled and so far successfully completed 2 offline with 13 days each and 2 online. Today is the last lecture by Dr. MS Sudarshan sir. And also as a part of the upskilling program, we have taken a lot of construction sites also. And one of the things I have to mention, we have all taken to that metro sites. So because the metro work is going on in a big way in Bangalore, therefore you may all the engineers, all construction engineers must know that what are the activities are going on in Bangalore also. We visited the tunnel boring machine site and also the tunnel lining element casting yard. See, actually, we all observed how they are casting, what is the finishing, and what is the grade of concrete, what is the mixed proportions, all those things. And in that aspect, this is the last lecture. I request all the participants to interact with the today's speaker. And this is also a very important topic, the non-destructive testing. See, actually, the quality assurance and quality control and quality evaluation we have discussed in length and depth during offline. So what is the assessment qualities are available with respect to the finished structures? See, this is... Bartha, sir. Hello, sir.
Sir, carry on, sir.
Yeah. With respect to the assessment of the structures, one of the technique available globally is non-destructive testing. The non-destructive testing will give the idea about what is the quality control we made and quality assurance we have done during the construction stage that can be assessed with NDT. And also this knowledge is required for all the construction engineers with respect to repairs, rehabilitation, retrofitting of structures. And also I can say conditional assessment of the structures in one word. See, Dr. MS Sudarshan sir is expertise available and he is going to share all his knowledge to all of our rest gathering. I'm very happy and honored to welcome you, sir, on behalf of the center and my the participant. I welcome you for this last day program. Thank you very much, sir, for accepting our invitation and sparing your valuable time with us. Thank you once again on behalf of the Skill Center. And also I welcome all the participants who are all eager to hear the lecture on non-destructive testing of concrete structures. It is a need of the hour for all the construction industries who are all working as a site engineers or any other infrastructural development. See, this is required. And also I request all the, and also I welcome Engineer Ashok and online coordinator, Mr. Sanath Kumar, and all the participants joined in other states also. I welcome Dr. Ramadevi. She is also heading a Structural Technology Center at Coimbatore. And also I welcome all the dignitaries who are all there. And before going to that lecture, just a brief introduction about the speaker of the day, Dr. MS Sudarshan. See, Dr. MS Sudarshan is graduated from Mysore University, BE Civil from Mysore University, and MTech from IIT Madras, Chennai, and also PhD from Visvesvaraya Technological University, Belgaum. Sir has joined as a L&T. He joined 1984 and worked 4 years as a design engineer in L&T Construction Group, ECC Chennai. You all know that this is the #1 construction company in India. And also he worked as 88 to 98, worked as a Deputy Chief Consulting Engineer in Torsel Research Foundation, India. It is meant for testing on building materials. And 1998 to 2011, worked in Civil Aid Technology as a Managing Director, Civil Aid TECHNOCLINIC Private Limited, Bangalore. And 2011 to 17, Civil India Bureau Veritas as a Senior Director. And from 2017 onwards, Managing Director, STEDRANT TECHNOCLINIC, Bangalore. It is the biggest test house in Bangalore and Hyderabad. More than 200 employees are working in this organization. and is NABL accredited lab. Dr. Sudarashan sir is the managing director of this company. And also his area of interest includes structural designs, non-destructive testing of structures, evaluation, restoration of structures, geotechnical investigations, quality monitoring of structures. These are all, this is the knowledge required for all the construction engineers. Now it is an advantage for the participants to, we are going to take care. And also, sir is having a lot of affiliations, member of Indian Concrete Institute, Association of Consulting Civil Engineer, Indian Geotechnical Society. And also, I'm happy to share that sir has worked as chairman of Association of Consulting Civil Engineers, Bangalore Center during the year 2009 to 11, and also worked as a Secretary General ACCI for the term of 2013 and 15. And lot of undergone trainings in other countries. The 3 weeks training program at AOTS Osaka, Japan. And also the countries visited Japan, Thailand, Malaysia, Saudi Arabia, Dubai, Qatar, Mauritius, Sri Lanka, and on assignments. And participated many number of conferences, workshops, and presented more than 60 plus guest lectures with respect to case studies, and also published the majority of the publications based on the case studies. So today, I think sir is going to share what is NDT or how to assess. NDT is easy to conduct, but to draw inferences, the outcome is very, very tough. Now I don't want to take more time on that. I request Dr. M.S. Sudarshan sir to take over the session. And also I request all the participants, you can post only in the chat box. The questions will be taken at the end of his lecture. Thank you once again to all of you. I request Sanat Kumar to mute all except the speaker.
Thank you, Professor Babu.
Thank you, sir.
Thank you for providing me this opportunity to share my experiences in non-destructive testing of concrete structures. And I also thank Professor Babu and Srinivas Kulkarni for heading this center and doing many good things for the development of our civil engineering fraternity. So let me start my lecture.
Full screen agata sir, full screen?
Yeah.
Okay. Thank you, sir.
So non-destructive testing of concrete structures. I would like to divide this into two parts. One is NDT for concrete structures, and what are the tools that are available, what is the need for the test to be conducted, and how it is done and how it is interpreted, what are the tools that are available. And then a typical case study of one of the structure, how this equipment or the NDT is used for the evaluation of the structure, and what are the inferences that could be drawn, and how the repair can be worked out based on the study. That's how I have framed my presentation. So coming to non-destructive testing. So why do we need non-destructive testing? So it's mainly to ascertain the quality and or strength of concrete. And once we know the quality of concrete and structure as a whole, it gives some idea about the overall quality. So what does this ND testing indicates? We can find out what is the quality of in situ concrete, and then we can compare it to standards and then see whether it will conform to the standards or the specifications for which the building is or the structure is constructed. And then if there are any deteriorations setting in, even that can be found out, and it can be alarmed. And then if there is already some deterioration set in, then we can find out what is the magnitude of the defects. Has it reached a dangerous level, or is it still in the nascent stage, or is it in the intermediate stage? And so it will help us in working out the suitable repair measures or the restoration measures. So the extent of distress can be found out. And again, we can also assess the durability of the structure. So we can by knowing the quality of the concrete, and then the various parameters like depth of carbonation, and then the cover provided to the concrete, the reinforcements and all that, and its in situ permeabilities, we can arrive at what is the durability of the structure. All these things can be arrived at through NDT. So why do we need NDT? There are many applications for which the non-restrictive test is required, and then which is quite popular, and then people are resorting to this kind of testing and evaluation to know about their structure. So what are the reasons, or what are the situations wherein such studies are required? One is to assess the quality and strength of the construction, which is still under construction, when normal tests give low results. Suppose you have cube strength, cubes cast, and then you find that the cube results, it gives a lesser value than the required concrete strength. Then what do? You cannot break the whole structure, because there are many aspects for the test or the cube test. It maybe you might have cast the cube improperly, or maybe it is not cured properly, or maybe the testing methodology and the testing equipment itself may be defective, or the cube testing machine may be defective. There are so many results, so many reasons. So you cannot really just right away, you cannot disqualify the concrete. So what are the other methods? Then you can resort to NDT to find out whether the in situ strength is it achieved, whether the quality of concrete is good, and then you can arrive at the suitable conclusions. Then as conformity tests in new constructions. So once the overall the construction is over, sometimes many clients, they would like to know how is the overall quality of construction, because they're all constructed in different timings. Maybe it might have taken over a period of 1.5 years. So they would like to know how is the overall quality of construction. So for that, a series of NDT tests can be done to evaluate, and then we can tell them that what is the status of the quality of construction. Many times this will be required when there are people who would like to purchase the building which is just completed. Maybe they would like to house their IT industry or IT park. So they would like to buy the building, and before they want to buy the building, they would like to know, because they were not present when the construction is being done. So they would like to know whether the structure can be viable or not. How is the quality? So in that case, also we can do a series of NDT tests, and then we can tell them what is the actual quality of the construction is. Then the structural evaluation of existing structures. This has become quite important nowadays, because after a few years, they would like to know how is the quality of the structure. Is there any distress in the building, so that it can be taken care, or whether it is still livable? Can we, with minimum whatever the maintenance, can we keep this structure for a more time, or something needs to be done? Especially in commercial and public structures, this is required. So the existing structures need to be evaluated, and NDT becomes handy. Then feasibility studies for additional floors or constructions. Many times we find that now, due to increase in land value, people would like to go for additional floors or extensions in the existing buildings. So usually most of the buildings, once they are more than 4 to 5 years, structural drawings or the structural details are hardly available. They are not available at the site at all. Or the person who purchases it, he will be having some whatever the electrical layout and things like that, but the structural details are not at all available. So then he would like to put one more floor. So what is he, how he can find out whether the structure can take up the additional floor or not? Then this NDT can be done, wherein we can find out the in situ quality of the concrete and also map the reinforcements from the profometer, and then collect the data, carry out a reverse analysis or a theoretical analysis, and then check up whether whatever the details that are there in the existing in the structure, can you take an additional floor or not. So this kind of feasibility study can be done. Sometimes you would like to, there is a change of use. So like you would like to put a battery room, you would like to give it an IT and put a battery room, and you know a battery room will have very high flow, very high loads to the order of 1 to 1.5 ton per meter square. And most of our commercial buildings are designed for about maximum of 400 to 500 kg per meter square live load. So in that case, where they are going to house all those batteries or any additional loads, even that need to be checked for its structural adequacy, whether it can take the load or not. So such studies can be done through NDT. Then suppose there is a problem in the structure and there is some distress, some cracks, some deflections, some leakages happening. So we would like to know what has happened to the structure. Is there any problem with the structure, or why this distress is happening? Then through NDT, we can find out what is the distress. And we can also find out what is the extent of distress. Is it really alarming, or is it in the intermediate stage, or is it a very mild stage, and whether it can be repaired. So once you know the extent of distress, it will be very easy to work out the extent, the suitable restoration measures. And the last one is now picking up, especially in more and more educational institutions. I think the central government is asking them to provide the what to call the building stability certificate. The colleges and schools, they have to provide building certificate, stability certificates, and for carrying out such condition assessment of those existing structures, non-destructive test is a must. In fact, already prescribed that non-destructive tests have to be done, must be done to carry out the structural stability study of all the educational buildings. So these are some of the situations or the requirements wherein our NDT will come in very handy. It's not just limited to that. These are some of the situations wherein we have encountered, and then we have carried out studies. Now, what do we find out from the non-destructive tests? Actually, we find out the quality and strength of concrete, and then the durability aspects. We can find out the deterioration, and then we can arrive at the structural capacity. So these are the 4 important properties, or the important things which we arrive at through NDT. And as you know, once we know all these 4 factors, we can easily assess the existing status of the building, and then we can provide whatever the requirements. To arrive at all these things, there are various methods that are available. So the testing on the concrete structures, it is basically divided into 4 parts. We have non-destructive testing, and then we have destructive testing where we can test it to fail, and then we have semi-partial destructive tests, and then the performance test. So basically, the testing is divided into these 4 types. So these are the typical the definitions. Non-destructive test means testing the structural members without any destructions or damage. So we don't do any we don't cause any destruction or any damage to the structure, and then the tests are carried out. Semi-partial destructive test is the testing of members with minimal damage but not affecting the structural integrity, like we take core test or we drill a hole. So these are all some localized damages, minimum damages we do, but which will not affect the structural integrity. But still there will be some minimum damage done. So they are all, that's why it's called as a semi-destructive test. Destructive test is basically done on recast elements or typical members wherein we would like to know what is its failure load or what is its structure ultimate load carrying capacity, and then we test one of those members to failure. So they are all destructive tests because that element cannot be used afterwards. And performance tests where we evaluate the performance without causing major damage. It's like load test or the pressure test and all that, wherein we load the structure to the required loading, maybe about 25% more, and then we observe what is its performance, how much is going to deflect, is it going to develop any cracks or not. So those things we would like to be observed. So to ascertain its structural carrying capacity in case of load test, and during the test, in case we come across any problems, immediately it will be unloaded. So here also the structure is not going to undergo any major damage. So these are the basically the 4 types of tests. And coming to our non-destructive tests for our studies, these are the devices which we use normally. I think most of you know the basic and then the very simple ribbon hammer test, Smith ribbon hammer test, then UPV ultrasonic pulse velocity device, impact echo tester, tomography scanner, which has come recently into the market and it's becoming quite popular. Then cover meters, ground penetrating radar, Hofstra Potentiometer test, field permeability apparatus, endoscopy, boroscope, crack measuring devices, infrared thermography, file integrity test. Of course, the list goes on. So I'm limiting to this. You can find out many more. Coming to semi-destructive tests, we have laser probe test, we have cross-hole sonic logging test, and then Capo test, lock test, bond or addition test, core test, then chemical kit for testing of hardened concrete, wherein we take a sample of concrete and then test it for chlorides and sulfates at the site, then performance load test. So some of these methods I'm going to cover in my presentations. And there is a lot of study which has been done on these non-destructive devices, and then it is very well covered in various standards and regulations all over the world. So these are some of the listing which I have done, so that in each country there is a standard which has been developed for these non-destructive testing. For BIS, latest is we have IS 516 and then 456, which will give us the details about this testing and the interpretations. So like that, you have so many standards from so many countries. So coming to non-destructive, let me take you through a few instruments. So this is the basic instrument, the ribbon hammer test, which is the N type, which is normally used for, because we have different types of ribbon hammer tests. Ribbon hammers for masonry, for mass concrete, and then for thin members, and then for normal concrete. So for normal concrete, N type is very widely used. So what it does, so it measures the in situ strength of concrete near to the surface based on the hardness and penetration resistance. And hammer, it measures the rebound of a spring loaded mass impacting against the surface of the member. The plunger of the hammer will hit the concrete surface with defined energy. The energy is, once it is released by the spring, and its rebound depends on the hardness of the concrete and is measured by the test equipment. And then there is a reference chart, the given of concrete, and based on rebound value, you can find out the compressive strength. So this is a simple section which explains the working. So you have this spring and you have this plunger and you have this mass. So you go on pressing this and then the spring elongates and then it goes on imparting certain energy. And once it reaches this latch, it gives way and then this mass falls onto the plunger. And depending on hardness, this plunger rebounds. And the rebound, for example, if this is very hard, then the whole impact energy gets rebound. So you get a high value. Suppose if this is a soft surface, then you get a mark here and then the rebound will be less. Then you get a low rebound value number. So this rebound number, there is a counter here wherein you can measure the rebound number in terms of number, and that number is correlated to the strength of concrete. These are all some of the advanced versions where nowadays you get rebound hammers with recorders, or can be with chips wherein it can be easily stored. So these are some of the latest equipments, digitized rebound hammers that are available, and even you can load it or feed it with the calibration strength so that you get the concrete strength directly. So if you have a calibration chart and then that can be fed into this, and then when you hit, instead of getting a number, you can get the strength of concrete. So these are all the latest ones which are available. And of course, the test requirement is that it should be conducted on the concrete surface. It should never be done on a plaster surface. So in case the structure, in case that member is plastered, which happens in most of the existing structures, you have to cut open the plaster, expose the concrete surface, clean it, and then make it as smooth as possible, uniform, and then you have to carry out the test on the dry concrete surface. You should not do it on a wet concrete surface. So one has to be quite careful. And at any point, when you choose a location, you have to do at least about 10 hits around that point, and then take an average of all the 10. That's how it has to be done. You should not do only with one hit and then take that number as the rebound hammer reading. That's how it needs to be done. Of course, there are many variables for this. This rebound hammer, it depends on the type of cement, and it's very sensitive to aggregate type. In fact, there are many calibration charts for different aggregates. And as I told you, it should be a dry surface. If it is a wet surface, again, you are going to get different readings. And it should not be a carbonated surface. Carbonated surface means you see some white patches coming on the concrete, which is due to the calcium carbonate coming to surface and then getting oxidized, becoming calcium carbonate. And calcium carbonate is very hard. So if you hit rebound hammer on that carbonated surface, you are likely to get high reading, and it will not give you the true picture of the strength of concrete. So it should not be a carbonated surface. So one has to be, even though it looks a very simple test, one has to take a lot of care while doing that test, because you get a very wide range of readings sometimes, and you have to, you have to leave out the freak readings, or at a given location, if you are getting low readings, you have to find out further, examine why you are getting such low readings. Maybe it may be a debonded or delaminated concrete due to corrosion, or maybe some other reason. So you have to find out exactly why you are getting low readings, and that's how you have to arrive at it. Types, you have P, L, L9 for different applications. For example, what you see here, this is for masonry structures. And one thing what you see here is the anvil. This is very important, because as I told you, this rebound hammer, it has got a spring inside. And every time we hit the rebound hammer, the spring elongates and contracts. And it has a life, maybe about 5,000 or 6,000 repetitions. Afterwards, the spring will loses its stiffness and your readings will not be the correct ones. You may start getting erratic readings. So that is why before you do test every time, you have to do this calibration using this anvil. What we do is we take this and then we put the plunger in this and then hit it. And when you hit it on this plunger, there is a number given here, like it says 25, 35, 32, like that. Your rebound hammer should show that reading. And only when it shows that reading, that means your spring is still in good condition. Then only you can use it in the field. And if suppose if it shows a very different reading other than this, that means your equipment or the rebound hammer needs to be, spring needs to be changed or it needs to be serviced. So before you do the test, please see that you always check it with respect to anvil and then only carry out the test in the field. This is how the tests are done. Either it is done horizontally or vertically or different situations. If you want to do it on a floor slab, then it is down held vertically. Columns, it will be horizontal, or if it is a slab ceiling, it will be vertically held upwards. And when it is held in different positions, the mass will be moving either against the gravity or it will be moving towards the gravity. So accordingly, the rebound hammer numbers will also change and we need to do the corrections. So these are the corrections given by the instrument manual. For example, if it is an upward, what happens is your weight is going to be drawn by the gravity and hence you are likely to get a less reading. So then, sorry, you are going to get a higher reading and then your correction has to be, because when the rebound is occurring, it is drawn by the gravity and so you get a higher reading. Then your correction has to be negative. So that's why you get a negative correction. Similarly, when you are holding it downwards, when the rebound is occurring, it is going against gravity. So that means it will give you a lesser reading. So you have to do a positive correction. So these are the corrections given by the instrument manual, and every instrument, whatever you purchase, it will have these corrections, and this should be adopted for the rebound hammer tests which are done at different positions. So if all the factors are taken into consideration, the strength of concrete can be determined with an accuracy of about 10 to 15%. And then when the little information is available about the concrete, then the possible error could be even up to 25%. So this percentage of prediction, it depends, goes with the experience. So a person who has good experience, who does the test properly, then the accuracy can be, the error can be less and less. Coming to ultrasonic pulse velocity test, this is measured through the pulse velocity, which is passing the pulse velocity through the body of concrete. So the measurement of ultrasonic pulse generated through the piezoelectric crystal probes to the concrete, which is indicated in the timing device. So it is used generally to check the quality of concrete, the compaction, the uniformity of concrete, delamination of concrete, cracks, presence of honeycombs, voids, etc. One thing you have to be careful, ultrasonic pulse velocity test will not give you the strength of concrete. So if you have to go for the strength, either it is a rebound hammer test or you have to go for core test. Whereas for a lower grade of concrete, up to about M25, you can generate some calibration graphs to arrive at the strength of concrete. But anything more than M25, the readings are going to be almost same. Like for M40 concrete and M30 concrete, there is not much of a difference in the ultrasonic pulse velocity values, and hence it is very difficult to arrive at exactly the strength of concrete through Qpv tests. These are the natural frequency of the transducers. Like use the two probes, and these probes will have piezoelectric crystals, and they produce the waves with these natural ultrasonic pulse velocity waves with these frequencies, and for a given minimum dimension of the member, then we need to go in for the suitable probe. So for example, if our minimum member size, minimum traverse distance is about 150, then it has to have a transducer having a natural frequency of more than 40. So like that, you can have the transducers for given or the desired path length. So because most of our structures are more than 150 mm, so usually we go for this type of transducers. This is how the test is done. So you have two probes is held on either side, and one is a transmitter, other one will be receiver. Then the ultrasonic pulse passes through this, and then whatever the distance or whatever the time taken for the pulse to pass through, it indicates here in microseconds. So for example, here 33.2 microseconds, and this is a cube, and you know what is the path length? 150 mm. So 150 mm divided by 33.2. So that gives you the velocity, and that velocity in terms of kilometer per second or the meter per second, you can find out the quality of concrete. So here also we have, depending on how we hold the probes, there are three methods: direct transmission, indirect transmission, and semi-direct transmission. It depends on the accessibility of the given member and then surface which is available for testing. For example, in the direct transmission, in most of the beams, columns, so you can put the two probes on either side of the parallel surface, on opposite surface, and this is a much easier and the best way of doing the test, wherein there is a direct transmission which happens. Otherwise, suppose if you have a column which wall built on either side, you have only two faces available, then this is a semi-direct, wherein the two probes are kept on adjacent faces. Suppose you have like a pavement slab or a retaining wall, wherein the outer face is not available, only one face is available, then this is done by keeping both the probes at a known distance of about 300 to 400 mm, and then this test is conducted, and this is known as indirect methods, and this is the least preferred method. So first thing is, if possible, most of the times we would like to go for direct transmission, and in case of any inconvenience or if there is no availability of direct transmission situations, then we go for semi-direct, and this is the least, the indirect method. This is how the latest Pandit lab, which is evolved, and then the test is done, and then you can here also where you can key in the width of the transmission length, so you can get the velocity directly. For example, 62.9 microseconds is the time taken for the ultrasonic pulse velocity to pass through, and once this width is fed, you will also get the velocity in meter per second. So these are same ultrasonic pulse velocity testers, which are produced by different manufacturers like USD UK, different brands and different shapes, and Cosmos India also produces, and this is by from the UK, And then we have most of the thing is these POSEC equipments are quite popular. So ultrasonic pulse velocity again depends on many factors like the aggregate size, the minimum path length we choose. It should be at least more than 4 times the aggregate size should be. That means if you are most of our concrete members are made with 20 mm down size aggregates we use in concrete. If that is the case, then your minimum size should be at least 100 mm, 85 to 100 mm, so that you can use this test. And if it is in a mass concrete, and if you are having 40 mm down aggregates and all that, then you have to go in for a bigger path length. And wetness of concrete. So the concrete, when we are testing, it should be dry. And once if the concrete is wet, then it can pass the pulse fast, and then you get very good ultrasonic pulse velocity readings. And this can be quite deceptive because you get very high ultrasonic pulse velocity reading telling that the concrete is good, very good, the quality is excellent. But if it is allowing water inside, that means it's porous. So the reading can be quite defective. So that is why if there is any wetness in concrete, or if there is any rainy day and all that, then it is not preferable to carry out ultrasonic pulse velocity tests. The temperature of concrete, because our piezoelectric probes, they are quite sensitive to temperature. So anything more than 40, 42 degrees, these pulse velocities, these probes will not work. So hence, if you are doing any test on a very, very sunny day, or in the regions like Gulf countries, or in northern part of India where the temperatures are very high, then you have to discontinue the test. So you have to do the test either early in the morning or late in the afternoon. So if when the temperature is high, you should not do the test because you will not get correct readings. And if you are having any electrical currents nearby, suppose if you are doing test in electrical substations where there are static electricity situations, then you should not do the test because your readings are going to be erratic. Either you have to ask them to switch off the current electricity and then do the test. Similarly, if you are going to do the test on any turbo generators or generator foundations which are working, then you should not do the test unless those are switched off, because you have electrical current, static electricity, and you will also have vibrations. And if there are any vibrations inside that concrete, then also you will not be able to get correct static or stabilized readings. So then you will not be able to get correct readings. So you have to discontinue the test, or you have to ask them to switch off the machine and then carry out the test. And it also depends on the stress level in concrete. Of course, there are some studies which they have done to find out at different stress levels whether there is a variation, and it shows that there is some variation with ultrasonic pulse velocity results. And if there are any reinforcements in the vicinity, and when you do the test, you get very, very low path, or the time taken, and like you get only 5.6 like that microseconds as the time for the time taken in the when you pass the pulse. So that shows that the pulse is passing through the reinforcement, and you have to shift the location of the force. So these are the pictures showing different methods, direct methods, and of course a very simple calculation. Velocity is given by path length and the time taken expressed in kilometer per second. And of course, if there are any factors, are there appropriate correction factors? As I told you, various the height should be applied, like for the temperature and all that. And this is the grading chart given by our Indian standards, the latest IS 516. Earlier, we had only one chart for all types of concrete. Now, latest in 2018, they have given two charts for one concrete less than M25 and for concrete more than M25. Earlier, whatever we had for less than M25, I think that was the common for all concretes, but now they have provided two different charts. And as I told you, one less than M25, below 3.0, doubtful, 3.5 to 4.5 is good. And if you are getting more than 4.5 kilometer per second, it's excellent. And for concrete, which is more than M25 grade, if it is below 3.75, it is doubtful. 3.75 to 4.5, good. And above 4.5, it's excellent. So you can find out here, above 4.5, it's almost the same. So it doesn't depend on any grade of concrete, or it cannot give us any indication about the strength of concrete. So that's why I told you have to be careful when you do this test, because you cannot get the strength of concrete from ultrasonic pulse velocity test. And of course, in case when you get a doubtful quality, we may have to carry out additional tests on the structure to confirm whether it's really a doubtful concrete, or it may be an isolated region which is showing that doubtful concrete. So such tests have to be done. And in case we want to, as I told you, below M25 grade of concrete, you will be able to predict the strength to with some accuracy. And for that, you have to establish your own calibration chart. You have to cast cubes with various strengths, and then you have to find out its ultrasonic pulse velocity and also carry out compressive strength test. And then you have to put on X and Y axis the ultrasonic pulse velocity, and then the strength, and then draw a calibration chart. So you can make your own calibration chart, and then that can be used for strength assessment. But as I told you, for a higher grade of strengths, more than M25, you will not be able to predict this accurately. This is one of the applications which we carried out in the usage of ultrasonic pulse velocity. Actually, in most of the power plants, when they put TG foundations, and then before they erect the turbo generator foundations, TG foundations, it's mandatory to check the quality of concrete through non-destructive testing. And it's a huge structure. You can see here, it's a huge structure, and then quite the depth will be around 1.5 meter slabs, and it's an elevated structure, and they would like to find out the overall uniformity and the quality of concrete. So for that, we have to make a grid of 300 mm by 300 mm, and then each one is a position where the probe will be kept. So wherever it's possible, either you can do with a semi-direct or with the direct. So for example, this surface you can do direct, this wall you can do direct, this block only semi-direct will be possible, this only semi-direct will be possible. So like that, you have to devise the method, and then you get more than 3,000 to 4,000 readings. You have to analyze it, you have to plot it, and then come to a conclusion whether the concrete quality is quite uniform or not. So this is one of the tests we carried out. That's how this marking is being done. And what you see here, this is a grease being kept, which is used as a couplant for the probes. And this is the top of the generator foundation. And this is how it is done. And then, for example, in this, we do only with indirect is possible. And for this, you can do with direct. So like that. So all types of methods we use. And then based on this, we carry out the test and then plot all the values, and then we will come to a conclusion regarding the uniformity and the quality of concrete. So these are the limitations of ultrasonic pulse velocity test. Larger path lengths, you need some attenuators, and then maybe about maximum we can go is up to 2.5 meters, and beyond that you will not be able to get good readings, because whatever the ultrasonic pulse comes, it gets diversified or it gets dispersed, and hardly you will be able to receive anything. So larger path lengths, again, it has a limitation, and very thin members, as I told you, it has a limitation, and it can help only in the quality grading, good, better or excellent concrete, but no strength determination. And local deformity in concrete, it will be very difficult, because unless we probe that exact area, we will not be able to find out a localized deformity or the location of deformity. Suppose there is a 1 meter thick member, and then the defect is somewhere 30 centimeter inside the member, and when you pass the pulse, either you don't get a reading or you get a very low reading, which shows that there is some voids or honeycombs inside, but you will not be able to exactly tell where that void is. So the location of deformity, you cannot do it with ultrasonic pulse velocity. Of course, accessibility for testing is a challenge, and it depends again on the type of structure. So with all these limitations, still this is a very handy and then very useful test, which can be used to arrive at the quality of in situ concrete. Then we have impact echo tester, wherein here earlier we had one transducer and one receiver, wherein the pulse was passed through, whereas here you have a single probe, and then we produce a small impact on the surface of the concrete. The impact, it passes inside, and then it comes back, and then the probe receives the impact vibrations, and then that is again analyzed. So the resulting displacement versus time signals are transformed into frequency domain. So the plots of amplitude versus frequency are obtained, and then multiple reflections give rise to transient resonances, which can be used to evaluate the integrity. And in a solid structure, it gives a distinctive wave formations, and the spectra is produced. And if there are flaws, then the patterns gets disrupted, and depending on the pattern, we can find out what could be the defect inside the concrete. And this is a very powerful, useful when only one surface is accessible. This is how the test is done. So you have a transducer receiver, and then you have a small hammer, and then you give a small impact blow. The vibrate or the waves produced, it goes into the concrete, and then once it has a hard surface, it comes back. Suppose if this is the end of concrete, and if there are no flaw inside, the wave travels inside and it comes back. So you know the depth, and then you know the time taken, and then based on the signal, you can arrive at whether it's a good concrete or not. And suppose if there is a flaw, it returns much faster, and depending on, there will be multiple waves coming. So one wave may go up to this and come, there will be one wave coming and like this. So you get a multiple wave patterns, and depending on that, you can wave forms, you can arrive at what could be the problem. For example, if it is a solid, you going to get a single wave here, signature, and then if there are some partial voids or any crack, debonding, like that, deformations, so you get waves like this. And if you get a big void, then the other pulse may not go through, and you get a very good, again here, but much delayed distance. And then if you are having honeycomb, you get signatures like this. So based on this, you will be able to determine what's the defect in the concrete. So this is how the test is done. Probe and a small hammer. So it can be tested on beams, slabs, concrete, retaining walls, and all that. And one thing is that it's test is done only on one at only one location and one point, and you have to carry out at number of locations to find out. And there is an improved version of this, which is called as ultrasonic tomography, which is a combination of this impact echo and also the ultrasonic pulse. Here it has got a series of probes, which has about 40 to 45 transmitting and receiving transducers, and then each of the probes can act as either receiver or transmitter with a default operation ultrasonic frequency. So when you run this device on the surface of concrete, and it gives a number of signals, and all this, it measures the time of signal propagation between the transducers at fixed distances for material velocity calibration, and uses the synthetic aperture focusing techniques, which is a software technique for analysis in scan mode, reconstruct the medium below the measurement based on the air wave reflections. That means you have a number of probes which are going to give. This is a equipment, and you can see there are a number of probes here. So there are about 40 to 50 probes, and this comes with the analyzer, and it can give you the 3D images of the concrete and what is inside concrete. It can directly tell you. So this operation applies echo technique, and it is one side access to the object. So even if one side is available, you will be able to use this instrument. And this instrument is feasible for concrete inspection, for searching the conduit ducts, conduits, and the health of pre-stressing cables. If there are any foreign inclusions, holes, honeycombing, cracks, and other defects inside the concrete objects. And the advantage of this is that it can actually locate where the problem is, and it can give you a 3D picture of the concrete. So this is how it is done. So as I told you, it has a number of probes, and then it gives all the pulses, and it passes through, and each one acts as both as a transmitter and a receiver, and you get a number of signals which is processed. So it can be used on one side, either in a tunnel lining. You want to know how good is the lining, you can use it, or on walls you can use, or you can use it on floor. So like that, any structural element it can be used. And this is how the images you get. You can get a 3D image, and then it can give you the location. For example, here, all these lines you see are the rebars. And if there are any problem below, it will show up, and then you can take a slice, and then you know exactly where the problem is. For example, here in this, this is the bottom of the member. That's why it shows one reflection. And there are some voids here. There may be some reinforcement lines, and there are voids here. So you can find out exactly the location and what depth. If there is any foreign material, or if it is a void. So all those things can be found out, and it can be sliced. And then, like our body scanner, you can take out the images and you can check. So this instrument is becoming quite handy and more and more useful, especially in thin members, and also in PSC members, and also in knowing if there are any problems, or if there are any surface cracks. You would like to know what depth the crack has gone in, extended, is it going through, or is it ending at some depth. So all those things can be done through this tomography. Then coming to parameter test, after concrete, we will go to reinforcement. Cover meter test, it uses electromagnetic pulse induction technology to detect the rebars. Suppose you have a slab, and then there are bars available, and then you would like to know what is the reinforcement provided, what is the spacing of reinforcement, and at what depth the reinforcement is there. So these things can be done easily with this cover meter or profometer, and it works on an electromagnetic principle. And on the surface of any electrically conducting material, which is in the magnetic field, the eddy currents are produced, and they induce a magnetic field in the opposite direction. And then the resulting change in the voltage can be utilized to find out the location of bars. So cover meter, it consists of a probe and a control box, and it's used to assess the concrete cover and then mapping of rebars. And it can also be used for estimating the size and diameter of bars. And one thing is the rebars which are very close to the surface can be detected. Suppose you have a beam with 2 layers of reinforcement, and whatever is the outer layer of reinforcement can be found out. The second layer of reinforcement cannot be detected. And if that is to be done, then you have to go in for different type of equipment. So this is one of the earlier cover meters or the profometer. Again, the PROSEC equipments, they came up with this kind of instruments. Initially, it was not digitized, it was with a meter. So you have to go on moving the probe, and suddenly when there is a change in the reading, then you know that the reinforcement is there in that location. So that's how this was used in the earlier days. In the 80s, this was the method, and now it has come out very handy. So you can just run or pass it over the concrete member. You will get what is the probable diameter and what is the depth. So there are the cover meters. It is named as profometers by PROSEC, and there are different types which have evolved, like profometer 2, what I showed, the very primitive one. Then it went up to profometer 3. Then we had profometer 4, which had different probes, one for the cover and one for the diameter. Now we have got profometer 5 and then profometer 6, wherein a single probe can be used both for determination of diameter as well as the cover depth. So this is the latest which can be used. So wherein you can also get a mapping of the reinforcement. You can scan over the area, choose the area, put coordinates, and then scan, and then wherever the bars are there, it will show, and then you can also take a printout of that. That's how this rebar scanner can be done. So either you can find out both the cover and the diameter at one location, or you can use it for mapping. So this is another by another company. Again, you can see here the rebars can be mapped. And Hilti has come out again with this ferroscan. This is also a very handy equipment wherein once you can just use this and then roll it over the concrete surface. So wherever the reinforcement, it will catch, and then it will give you a diagram or a drawing depending on where on the position of the reinforcement, and also you have you get the bar diameter. So this is one typical output image wherein you can find out the bar diameter and also the position of bars. Limitation, of course, it is very useful for our structural evaluation, where in the absence of drawings, we have to find out what are the rebars provided, what is the spacing, what are the numbers, and all that. So for that, it is very useful. However, the limitations are the bars which are very close to the surface, they can be detected. Second layer, if it is there, it cannot be detected. And then the accuracy of the diameter of bar, it will be generally in the range of 10 to 20%. Suppose you have you may get 18 mm as the diameter of the bar. So it may be 16 mm or it can be 20 mm. So like that, you have some 10 to 20% variation on the bar diameter. You may not be able to predict accurately because our most of the bars we use are what you call high yield strength bars, which they don't have a perfect round the diameter because of the presence of ribs and all that. You will not be able to accurately predict the diameter of the bar. And if the bars are placed very closely, like what we see in some deep heavy beams and all that, if the bars are placed very close to each other, then also it becomes a bit difficult to find out the actual number of bars. And generally, if the cover concrete is more than 60 to 75 mm, then it will be again difficult to locate the position of the bars. So up to about 60 to 75 mm in the normal cover meters, you will be able to find out the bars. But of course, now they have some new models which have come, which can go up to 185 mm. But the normal cover meters which are in the market, they will be able to go up to about 60 to 70 mm. So, but as I told you, in the absence of the data about the rebars, this is a very handy tool wherein we can find out the position, disposition, bar diameter, and all that in the structural members without really breaking open those or keeping open the concrete. Then we have this latest one, the ground probing radar. This is a geophysical method based on electromagnetic wave propagation. Earlier we have ultrasonic wave propagations or impact waves. Now this is depends on the electromagnetic wave propagation, because this goes to quite deeper depths. That is why we need a strong wave, and it detects the interfaces between the materials having various electrical characteristics. So when we place the probe on the surface, the waves go down, and whenever there is a different material or a void or is hit, these waves get reflected and again they are captured. And depending on the extent of the way the waves are captured, they are synthesized, and then we get a picture of those obstacles or those variations. And depending on the reflections, we will be able to arrive at the type of object inside or whatever the defect. So the system has an antenna which has both the transmitting and receiving probes, and then it has a central control unit which governs the characteristics of electromagnetic waves. It amplifies the received and reflected waves and converts into a digital format. And then we have a video display unit which receives the digital format, processes through the software, and produces a graphical output as a two-dimensional depth profile. This is a typical probing radar instruments. Earlier, it started with mainly our geophysical and geotechnical applications. Now, with these probes with higher frequencies, it has now come into our concrete structures as well. So, probe can be erected or it can be installed on the in a vehicle, and then you can just drive the vehicle, and then the central processing unit inside the car, it can collect all the data for processing. So it looks as simple as that. So this is a basic principle: the electromagnetic waves going in and then hitting at different surfaces, then gets reflected. You get different reflections, which are again synthesized, and then it comes out in a graphic format. So these are the different applications of ground probing radars. And suppose you have very short range up to a depth of about 1.5 meter, like our pavements, road structures, know about foundations and all that, bridge structures, and building structures, the beams and all that. So up to that, we use very high frequency probes, and then the frequency will be in the range of about 1500 seconds per second. And if you are going for a medium is there is that sometimes if the second layer of reinforcements, this can detect, but it may not be able to give you the diameter, but it can tell you whether this second layer of reinforcement is present or not. That can be done with this ground probing radar. And one of the applications of this GPR was in the inspection of Ayodhya site in Ram Mandir to know whether there are any underground structures. So the long range probes were used, and then with that they were able to predict that yes, there are something inside the ground. So this is how the application for concrete structures. So the central processing, it can be kept, and then you can move around. And this is a typical view of our slabs. You can find out, and then like all the bars, rebar, circular, it will give like a wave shape like this. So this shows that there is a top set of rebars, and then you have base set of rebars here, and then there is a beam here, and again there is a beam. It will not give you like what we saw in tomography. It will give the indication, and it requires sufficient experience to analyze these images. So you can see here different ways of doing this. Nowadays, this GPR has become quite handy. Even in small sizes, it has come, which can be used, and then you will get the image processor in small ones. And especially, and this application can be done for concrete structures. And in case if you have embedded pipes, this is how the image comes. So this slab, and then these are all the top layer of bars you get, and then this is the location of the pipes. So a circular will be shown as some sort of a parabola, because the images are coming, and then when they hit and all those things, finally a circle turns into a parabola. So like that, you need some amount of knowledge to decipher these images, and then based on that you can scan the concrete. So typical applications like GPR survey on walls, the retaining walls. So you can do with this instrument. So the advantage is that it's very handy. It can be moved to, and then overall structures can be, most of the surfaces it can be covered for scanning. And these are some more applications. If you're scanning a slab, as I told you, the rebars will be seen as parabolas and all those things. So they have done the test in the pipe location. So that's how these images come, and it needs to be analyzed. So the limitations are you need different antenna, different depths. For example, if you're going for deeper depths, you will need an antenna with lower frequency. And to analyze the images, you need again a proper skill and the past experience. Otherwise, interpretation is quite tedious here. And then the object and interferences are indicative, because you will not be knowing. Suppose you see there is a pipe inside, but you will not be able to know whether it is a PVC or a metal pipe, or what is the diameter and all that. You know there is a pipe, and approximate size you can find out. That's all. The location, yes, you can find out. But the actual object will not be able to find out. And of course, this always needs to be complemented with other investigation. So the advantage is you can find out and say that there is something inside, and then maybe it has to be checked with further investigation, maybe making a small hole or opening to see what exactly is that. And so you can pinpointly say if there is a defect, you can find out, identify, and then give the location of the defect, and then further what is the defect and all that needs to be checked with other methods. Then we come to Hofstra Potentiometer. This is an instrument which is used to find out the corrosion, the extent of corrosion in RC members. The Hofstra potential measurement, it essentially consists of measurement of absolute potential at the concrete surface with a reference electrode. The measured absolute potential is the criteria for assessing the corrosion status of the embedded members, rebars, and then the measured values are correlated with the standard values. So this is how the scanning is done on a structure when you have each one is a half cell. So you have a number of cells. So if you want to scan this, so instead of finding out, putting every time each cell and find out, so you can have the half cells in series, and then you can record the readings. So typically, scanning is the most what you call a popular instrument that is used. So it has got a copper sulfate half cell, and then it has got two electrical points coming out. One is connected to the rebar, and then one is on the wet concrete surface. So the wet concrete surface acts as an electrolyte to transfer the charges, and then the potential difference between these two will tell us millivolts. So like that, we can determine now in the you have a IS code which has come up for high-rise structures, our Indian standards, wherein they have made mandatory to make the measurement on field permeability of concrete. And I think these instruments are going to be used more frequently here afterwards. And you can find out the permeability either through gas permeability or water permeability. So here the gas or water under pressure is allowed to diffuse into the concrete media, and then the reduction in the pressure with time is an indication of the porosity in concrete. And based on the rate of reduction in pressure, permeability can be calculated. There are standard curves or the standard formulae which comes up along with the equipment, which will through which we can calculate the permeability of in situ concrete. It's quite a handy instrument. It can be erected on the surface of concrete, and then you can either supply water under pressure or gas under pressure and seal it. And then you note down the pressure. With respect to time, the gas or water gets diffused into the body of concrete depending on its porosity. And with respect to time, there will be a fall in pressure. And you can note down the fall in pressure with respect to time, and then calculate the field permeability of concrete. There are different instruments available which can be used, and this is a gas permeability apparatus. So now we have Boroscope. Sometimes this is quite widely used in medical applications, wherein like endoscopy, where if there is something wrong with the stomach, find out what is inside the stomach, they introduce a tool with an optical camera and light, and then they find out. And a similar instrument is available for our civil engineering applications, and it is called as Boroscope. It also has similarly a flexible tube, an optical camera with an eyepiece, and then illumination available. And this we can make a hole, then insert, or if there is a void, we can insert it inside the concrete mass, and then so it travels inside, and then you can know what's happening in actually inside the concrete. And actually, it's very useful in arriving in health inspection and health monitoring of embedded PSC cables in bridge girders and other concrete members. So this is how it is, the principle, and this is how it looks. So you can also attach a camera and then you can take photographs. And this is how the inspection can be done. And this is one of the pictures of a PSC of a priestess cable which got corroded, and then they wanted to know what is the extent of corrosion. And through this boroscope, they make a hole and then insert this, and then they can capture, know the status of corrosion in the PSC cables. So this is how it can be used. We have crack measuring devices. Whenever there is some problem or the distress, the building cracks, the structure cracks, and then we want to know what is the crack width, and we also want to monitor whether the crack is widening and all that. So there are different devices available. A simple graduated scale wherein you can place it on the crack and then find out what is the crack width. Or you have a optical microscope wherein you can read the crack width. Or you have a DMAC gauge wherein it can be fixed, and then if the crack widens, you will get a reading. You can monitor it. So this is mainly for monitoring the crack width, whether it's widening or not. And there are typical optical magnifying lenses which can be used to check the crack, and it has got a graduated scale inside, and then you can actually measure what is the crack width in millimeters. There are many things available. This comes with a lighting device, ELE. So when you place it on the top over the crack, so there will be, it gets illuminated so that you'll be able to measure it properly. Then we have infrared thermography. This is use infrared imaging and measure the thermal energy emitted from an object. And infrared energy is the light not visible to human eye, and it emits heat depending on the object or environment. And infrared camera shows the temperature difference between a color spectrum, and bright color indicates more heat. So this is the light spectrum, electromagnetic spectrum, and this range comes in infrared. It is not visible to the eye, but this can clearly bring out the difference in temperatures. And if that is captured through an infrared camera, then you can find out what is if there is any temperature variation on the surface of any object or concrete. So the change in temperature on an object on the surface of concrete, it can happen mainly due to dampness or the leakage. So when you take a camera, when you take a capture on the surface of a concrete or a wall, so if there is a dampness inside or a leakage inside, so you will get the regions which are damp, which may not be available to the, it may not be visible to our eye. So you can predict where the location of dampness and all that using this camera. So this is a simple picture with a coffee cup, and then when you take with an infrared, you see that coffee is there up to this because it's hot, so it gives different color changes. So these are the FLIR camera systems. They have developed a very unique cameras for our civil engineering applications, and they are available. So like this, they are quite handy. It can be captured and which can be downloaded, it can be transferred onto computer, and we can take images. So the practical applications of these infrared cameras are you can arrive at water damage inspection and monitoring, any water intrusion, and then building defect inspection if there are any. Suppose if you have any cracks, and then if there is a through and through crack or wide crack, and if there is any leakage or air circulation, air leakage, or air conditioning leakage happening, you can find out. So HVAC inspection, roofing inspection, you can do it. Plumbing and leak detection, you can do it. And electrical inspection, you can do it, because if there is any short circuit, or if there is anything, such problem, then that part of wire get heated up. And when you take a picture on the duct, so you will find that at some spots, heat is more, and then you can find out that there is a problem to be looked into. So like that, the applications are quite many. So for coming to our buildings, this is a picture of a building. So you can see that you have a two-story building. These are all the windows, and these are all location of columns, the slab. So this is a typical image you can get. And these are some of the applications. For example, if you see this building, you don't see any leakage at all from outside. But when you take it with an infrared, you find that there is a leakage in dampness. So like this, you will be able to detect easily. So there must be some leakage through some pipe which is leaking and giving dampness here. A similar application you can see here, again some pipe, and then this junction, there is some dampness leakage going in and all that. So this area, even though you don't see much here, but you see a lot of dampness here. Then on the roof, if there is any accumulation of moisture, dampness, and all that, so even though from outside you don't see anything, so these are the areas wherein there is some percolation and then accumulation of moisture or water, which can lead to leakages. So similarly, in the floor, you can detect. So any of the leakages or water intrusions, or you can easily detect using this infrared thermography. So the advantages is it's a very quick. It's just taking a photograph and then checking it, and it's a non-intrusive means of investigation. So we don't need to do anything on the existing environment, and it does not require any relocation of the occupant, and it's quite illustrative, and can use it for the confirmation of failure points and moisture migration paths. And the only disadvantage is it will not see through the walls, and only up to a certain depth, if there is a change in temperature, it can detect. And if there is a leakage quite deep inside, then it cannot detect. That's the only disadvantage. Then we have pile integrity tests, which is used to find out the health of pile, because once the pile is installed in the ground, so we do not know whether the concrete is good, whether there is the quality of concrete is fine, whether it has gone as a shaft or a cylindrical element. Are there any bulging out, necking? So are there any voids in the concrete? So we'll not be able to make out anything. And this is a very useful tool, instrument, through which we can find out the health of the pile. So it's a very simple instrument. It has got a pile tester analyzer. Then we have a hammer to give an impact, and then a probe or an accelerometer, which will receive the waves, and then it is analyzed. And then the signature of these waves. It's a very simple instrument. You have the pile, and then you put this accelerometer here, put it on the surface, and then you hit with a hammer, and then you capture a signature here. So on the pile, you do it about 3-4 locations, and then you capture the images, and then you have to do synthesizing all these images, to remove the noise and then remove the high frequency waves and all that. And then finally you get the waveform which is in the analysis, which can be studied further. And then once you get this wave, you can find out. For example, this is a good wave, good pile, wherein this is a starting location and you don't have much variation in this wave. And this is the end of the pile where you get a toe reflection. Whereas if you see this wave, you have initial wave, and then at some depth, you see large variations here. So that means there is some sort of a necking here, and then another necking here, and then so towards the end of the pile, there are some defects. And you can also arrive at what is the depth at which these defects are there. And depending on the signature, suppose you come like this and go up, then it shows that there is a bulging. And here, if it goes up and comes down, that means there is a necking. So like that, you can decipher what is the type of defect, and also you get the velocity through the pile. For example, here you get the velocity as 4,150 meter per second, which shows that whatever the concrete has been done in the majority of the location is good. But for this localized problem of necking, but the velocity of concrete is good, shows the concrete quality of concrete is good. And it also shows what is the possible depth of pile. So a lot of information you can get from this pile integrity test, which will be useful for further analysis. For how much time I have?
Interaction.
Hello.
Yeah, I'm audible, sir.
Yeah,
Yeah, time is there. How much I can continue, so no issue. Any queries are there?
Yeah,
So far,
shall we?
Dr. Sudarashan sir has given all the NDT test. And any queries from participants? I have only one query. In rebar corrections you are given, there is a percentage of correction, whether we have to take plus or minus, how to apply that correction. You mentioned the rebars may not be read exactly the numbers, diameter of the diameter size.
No, usually what we do is,
yeah.
Once we do the complete scanning and all that, at some location where which is there is a least disturbance, okay. We cut open, then we actually measure the rebar.
Okay.
Yeah,
based on that, we can take a call.
Yeah, based on that, we take a call.
Any other questions? Okay, sir, please carry on.
Yeah, okay, just let me proceed to the semi-destructive tests. Here we do some localized destruction or damage, localized damage to the structure. Of this, the Windsor probe test. Now this test is banned because here what we do is it has got a pistol and then it has got a bullet, and then we shoot it onto the surface of concrete, and then we measure the depth of penetration, and based on the depth of penetration we find out the hardness of concrete. But due to the possibility of this being misused, now this test is banned. Then we have a Capo test, wherein we can find out the in situ concrete strength. So what we do is this is the Capo test machine it is done on the existing concrete. So what we do is first we make a hole, and then we make a hole like this, and then we insert this what do you call a grip expansion bolt inside the hole. And then as you see here, it has got a spring here, and this, once it is inserted, this is rotated, and when it is like this, when it is tightened, this spring here it enlarges. So inside the body of concrete, it enlarges a bigger diameter. Maybe if it is a 10 mm or 12 mm diameter, it becomes 14 to 16 mm. So when you tighten it, it makes the groove inside the concrete in the hole, and then it enlarges into a bigger size. And then after that, we put the loading mechanism, and then we operate it like this. And then when it is rotated, the concrete, because of this enlarged base here, the concrete comes out like a frustum of a cone. So you see here, it comes out like a frustum of a cone, and the load which is taken for this failure is correlated to the strength of concrete. So that's how it is done in the Capo test. And similar to that is a lock test or a pull-out test, but this test is done on the preset anchors. That means the Capo test is done on it can be done on any concrete, and then the only thing is you have to drill a hole, insert this bolt, and then turn this, make it wider, and then pull out. Whereas in a pull-out test, even before the concrete is cast, these kind of inserts are fixed inside the concrete or inside the rebar cage using into the shuttering material. So you make a hole in the shuttering material, insert this bolt or the anchor, and then tighten it and then leave it. And once the concreting is done, at any age, you want to know what is the strength achieved, then you have to just de-shutter it, and then on the anchor, fix this device, rotate it, and then you will know the strength of concrete. So this is particularly useful in a pre-stressed structures, wherein you want to do a pre-stressing after concrete attains say 40 or 50% or 60% of the strength. So to know actually what is the strength that is attained by the concrete at any given age, this test is useful, but you need to do some sort of a pre-planning in the beginning, where to fix these anchors and all that. And once these anchors are fixed, you will be able to carry out the test at any given time. That is a principle how it is done. So like this, as I told you, this anchor has to be fixed in the concrete, and then it is put out. So this is how this test is done, the prefixed anchors. And then we have bond or adhesion test. Nowadays we have a lot of tiles and then coatings which are coated on the concrete or on the mortar surface. The tiles are fixed. So would like to know whether it is properly bonded or what is the adhesion strength. So then this test is used, and then first we make a core to segregate the coating from the rest of the body of the surface, and then you fix a dolly, a pull machine or a dyna pull off onto the surface with the coating, and then you do a pull out test. And so first you make a core. So that means you are segregating this, separating this area from the rest of the surface. Suppose you have done the plaster and then there is a lot of debonding, and then you would like to know whether the plaster is properly adhering, if there are any issues with curing, whether the plaster is properly adhering to the masonry or not, then you can do this test. So you are fixing the dyna pull. So this is the dolly, which is glued onto that drilled core, and then the pull-out is done. So based on the pull-out strength, you can find out what is the adhesion and then whether it is acceptable or not. Many times we use many anchor bolts or the rebar anchors which are embedded into concrete for further constructions and all. So then we need to check the pull-out strength. So for that, we have designed a device wherein we have a frame with the jacks, and then it is a pull-out. So So this is the self-supporting frame here, and then this is the anchor, and then we provide a fixture to the anchor and adapter, and then this is a load cell, and then using this load cell we pull the anchor, and this acts like a reaction frame, and depending on the force taken we will be able to find out what is the anchor capacity. So many times they say I want to test it whether it can take 3 tons, 4 tons and all that. So we add another 10% extra and we test it up to that. And in case they want to know what is the failure, what is the ultimate pull-out force, then we test it up to failure. So this is how this test can be done on the anchor test. Now core test is the most widely used and very popular test, wherein we take the core, and again the diameter of core to be taken has to be, we have to be quite careful. It has to be at least a minimum 3 times the aggregate size, and always bigger the core diameter, better the strength, or better will be the accuracy. So always try to, if there is a possibility, always try to get 100 mm core or a bigger diameter core. So that will really give you a most reliable results. And then the cores are taken through this core cutting devices. That's how it can be taken either from the core. So before we take the core, we have to make sure that there is no interference from the rebars. So we can use our profometer or the cover meter, and then find out the location of the bars, and then fix the location of core extraction so that we can take the core accordingly. So from the floor we can take, and once the cores are taken, they are trimmed, and then you have to maintain a perfect parallel surfaces for testing. So then you have to do capping, and capping is done either with sulfur or with high strength grout, and capping thickness has to be as minimum as possible, and we have to get a parallel surface, and after that it is tested in a compression testing machine, and you have a standard methodology to apply the corrections of a diameter, L/D ratio, and then a correlation between the cylinder, because core is a cylinder, and from cylinder to equivalent cube strength you have to multiply by 1.25. So with all these corrections applied, you will finally arrive at the equivalent cube strength. And if this equivalent cube strength, the acceptance criteria is if the average equivalent cube strength what we get from the course, it is equal to at least 85% of the cube strength. Suppose you have M35 grade and 0.85 times 35. So if your average equivalent cube strength from the course is more than 0.85 times 35, then you can say that it has achieved the M35 grade. So it need not be M35 and above. So it should be 85% of above, and any one of the cores can have strength between 75 to 85. Suppose you test 3 cores, and then one of the cores is more than 75 but less than 85, but still you can take it for averaging out. And as a performance load test, or the tests which are done to check to know the performance of the structure, and these guidelines are given in IRC standards, and for bridges, and for a structure it is given in IS 456. So we apply to the load equal to the full dead load and 25% of the imposed load or the live load, and keep it for 24 hours. We measure the deflection. The deflection has to be less than the critical deflection, and then when you remove the load, it has to be a recovery, and then the recovery of deflection is guidance, and for our structures it has to be more than 75 to 85%. For bridges it is 85%. For us it has to be 75 to 85%. These guidelines are given in Indian standards. This is one of the flyover load tests which we carried out. So here in a bridge or a flyover, the loading has depended as per the IRC and then the design. It depends on the location of the loading or the moving vehicle. So those locations have to be fixed, and the loaded vehicles has to be positioned at those locations like this. And then the deflections are measured using deflectometers, and then the 24 hours it is kept, and then the vehicles are moved out, and then its recovery is measured. So the recovery has to be more than 85% for this girder to accept. It will be in the acceptable criteria, and the deflection has to be less than the critical deflection calculated. So that's how the performance test is done. So it can be done either on the bridges or on the floors. Sometimes people will construct and they would like to load, and they would like to know what is the capacity to which it can load in a building. So we can take a typical panel, and then we can conduct a load test on the typical panel and find out what is its load carrying capacity, or for a given load whether it's capable of withstanding. Even that can be found out through this performance test. Now I'll come to a typical case study of structural evaluation we carried out on one of the structures. This is on an office building which was constructed during 2008-9, and it's a simple building with basement, ground, and floors. And over a period of time, the concerned authorities observed a few distress features like cracks in RC beams and slabs, cracks in masonry walls, dampness in plaster, deterioration of plaster, and so the occurrence of all these distress features, it started giving concern about the structural safety of the building. Hence, they made a reference to check the structural stability, whether it is good or not, or whether they have to vacate it or something needs to be done. So this is a view of the building, and you can see quite a bit of cracks and dampness and all that looks outside, and then so that's why they were scared. So these are some of the cracks on the outside, what you can see. And of course, the quality of construction was also not very good. You can see here a lot of gaps, and then the quality of mortar used in the masonry was also not very good. So these were the physical observations made. So we found that basically there was no settlement or the foundation issues, and then columns, they were good, there was no distress, and then cracks were observed in the floor slab in the basement, and the crack maybe could be due to improper compaction of soil, and then cracks were also observed in ceiling slabs, especially at the electrical conduit lines, and also at beams in a few locations, and dampness and damp patches, leakage was observed. So a similar thing was observed in the upper floors also, and there were also again some haphazard cracks in the ceiling slabs, and dampness, damp patches, and separation cracks between RC members and masonry walls. And on the terrace, there was a stagnation of rainwater at many locations, and waterproof plaster, whatever they had done, or the sealed concrete, it had debonded. So that could be one of the reasons for the dampness and leakage. And again, separation cracks were observed in the staircase room. And then the exterior, as I told you, as I showed you, there's a lot of cracks and the walls, and at the junction of RC members and masonry walls. So these are some of the views of dampness in the walls, in the RC beams, the junction of beam and slab, and separation cracks between wall and the beams, dampness, and then haphazard cracks in the ceiling slabs, and on the roof, the separation crack, debonding of mortar, and then the dampness marks, cracks. So that's why they wanted to know, is there any problem with the building? Is it safe? Or if so, if there is any problem, what needs to be done? So this is how the evaluation tests were carried out. First one was with dimension verification of typical structural members. We need the size of the members for carrying out the theoretical analysis. So that's why you do the dimensional measurements. And then we also tested the soil sample, have the value of the putting capacity of soil for our analysis. And then we did UPV tests on the columns and beams, then remote hammer tests on RC slabs, and the Permeability test map, because there is no structural drawings available. So we don't know what is the reinforcement provided. So we used a cover meter to find out the number of bars, the cover, and also the bar sizes in various RC members. And then we also did the core test on RC footings, because the RC footings are accessible only from one side. So it's difficult to do any non-destructive tests. So, and also the surface will be quite rough. So usually in footings, we take cores. So these are the various tests carried out: the cover meter test, rebound hammer, ultrasonic test, and then exposure of foundation, know the measurement, the size of the foundation, depth of the footing, and then taking cores, and again testing on the columns, and then because this structure had false ceiling, and not all members were visible or accessible. So we had to remove the false ceiling, go inside, sit, and then take the reading. So that's how it was done. These are the core test results. The footing showed very good strength with M35, and then based on the grade of the strength of concrete or the concrete quality, we arrived at the grade of concrete, and then that was used in the analysis. The reinforcement mapping, whatever is done with the profometer or the cover meter, that was used. And considering the age of the structure, it was about more than 10 years. So we considered FE 415 as a grade of reinforcement. So for the structural arrangement, whatever the sizes we noted based on the drawings made or the structural framework made, a 3D analysis was carried out. And this is how the analysis was done for various forces. And finally, these are the inferences which are arrived based on the evaluation study. So the dimensions of existing RC members were found to be in conformity with whatever the drawings that were available, they provided to us. And then the soil test, the SPC was found to be about 19 ton per meter square. And for that load on the column, the footings were adequate. And ultrasonic pulse velocity, see, even though there were some cracks in the beams and in the ceiling slab, but the ultrasonic pulse velocity and then the rebound hammer, it showed that the concrete quality is quite good. And then the grading comes under the category of good concrete. And then even the UPVT at the cracked locations, when we did the scanning, we found that because when you do a UPV, you keep the probe on either side of the crack on the opposite faces. If the cracks are through and through, you will not get the pulses passing through, and you get a very low velocity. But we found that even at the cracked locations, we get a very good readings. That means those cracks, they were restricted only to the surface, and the interior concrete was free from cracks. So this was a major inference drawn from the UPVT. And from the rebound hammer, the concrete strength is in the range of 30 to 35 Newton per millimeter square. That's why we considered a M30 concrete in our analysis. And then the cover provided to reinforcement was adequate. And from the core test, it was M25 concrete for concrete footings. And based on all these things, when the analysis was carried out, and from the theoretical analysis and verification, it is found that the existing building as it stands is structurally adequate to resist the present level of load safely, considering seismic loads also, as per the codal provision. That means whatever the distress, it was more of peripheral, and it was non-structural in nature. It was not a structural, and as such, the basic structure is safe. So this is what the inference we could get from the non-destructive test, semi-destructive test, and then the theoretical verification. So the haphazard cracks observed in the ceiling slabs, they were essentially due to shrinkage of concrete at the time of casting of concrete, and they were non-structural. And along the conduit line, whatever we observed, that may be due to the presence of electrical conduit very close to the periphery of concrete. So there is not enough cover concrete. That's why it's possible that the cracks have occurred at that location. And the cracks observed in the infill masonry walls, they were mainly due to the poor quality of mortar and improper workmanship, as I showed you. And then the damp patches observed in the ceiling slabs were essentially due to leakage of water from the plumbing, sanitary lines, and through the shrinkage cracks in the mother concrete at a few locations. And separation cracks between masonry walls and RC members are essentially due to differential thermal expansion, because those two are different materials. So the evaluation study clearly demonstrated that even though there are cracks, dampness in the building, structurally this building is safe. So what we need to do is how to treat for these distress rather than talking about the structural stability. So stability wise, the building was safe. That is an important conclusion which we were able to arrive based on this evaluation study using NDT equipments. So these are some of the restoration measures which we recommended, like for the treatment of dampness, treatment for cracks in RC beams, treatment for cracks, and treatment for separation cracks, and treatment for dampness in masonry walls. So like that, we had to prepare different sketches and then give them all the details. And these measures were carried out, and they are quite happy to continue to stay in that building. So whatever doubt they had about the structural stability or the structural health of that building, it was quite cleared due to this study. So just to conclude, non-destructive and semi-destructive tests are very useful in evaluating the quality of construction and to generate data from the structure, especially in the absence of details, as I showed you. And many devices are available for testing. Of course, maybe what I showed you, maybe only about 50 to 60%. There are many devices which are available, which can still be used. And of course, careful interpretation of results are to be done by an experienced personnel, because any misinterpretation can lead to problems. And of course, it is not that we have to depend only on one test and arrive at it. Has to be augmented with 2-3 tests, and then we can arrive at a proper conclusions. NDT testing is a useful tool in structural evaluation and distress mapping, especially when in the absence of data and all that. So I'd like to acknowledge my earlier organizations which were helpful in carrying out the study, like Offshore Research Foundation, Civil TECHNOCLINIC, Bureau Veritas, and the present STEDRANT. And also I have collected some information from the internet. So I acknowledge all those, the information obtained from various sources. So thank you very much for the attention. So if there are any doubts or any clarifications, I'll be happy to discuss.
Thank you very much, sir. Excellent presentation. It is a need of the hour for all the construction engineers. Must know that what are the various methods of NDT, because it has not taught in detail in the curriculum also, because I am there in 35 years. See, only where the engineering colleges labs are enabled accredited, they are all benefited. I think I'm happy to say that Dr. K. Ramadevi from Coimbatore, she's joined, where she is heading the test house also. So actually, Sudarashan sir has given clearly what are the various methods of tests available in NDT, and also how to conduct, and also what are the limitations. See, the construction engineers, whenever you are hiring or third-party inspection, nowadays all the works, CARDL, we are doing a lot of third-party inspection. All government project without third-party, they are not allowing. As a Nirmiti Kendra engineers and project directors who are all in this participation, my request is that you must aware of that what they are doing is right or wrong. You have a, if you know something about all these tests, it will helpful you to question them properly, whether they are doing properly or not. There are so many agencies not accredited by NABL. I have seen in the market, there are the competition is there, some report they are generating, and even sometimes it is NABL accredited with the old or dated also. Therefore, that is one of the reason why we arrange all these things. And the Sudarshan sir has given in detail what are the minimum tests required as per the infrastructural developments are going on. And now I request any questions from the participants. And this knowledge is required for quality assessment for the built properties, concrete built properties like strength, permeability, even many tests I come across from your presentation, sir. I'm very happy and honored to hear the many tests I have not involved personally. Now I request anyone. Sanat Kumar, any questions posted in Sanat chat box? Arpita?
No, sir. No questions are posted.
Arpita, no doubts. I think many of the tests, I think only they know for, I think rebound hammer and UPV also. And I hope you are given clear pictures. I think hence there's no clarifications from their side. I'm happy once again and thank you very much on behalf of the Skill Center and my own behalf. Thank you very much for your valuable time.
I have given my email ID.
Okay, sir. And also I already shared the resume of you, sir, for Nirmitik groups. And also I will share his contact and email ID. And this PPT is available in public domain because parallelly the YouTube lectures, all the online lectures are made YouTube. You can just go through that. Any clarifications required, sir has shared now the ms.sudarshan@stedrant.com. See any help required with respect to conduct of test, finalization of test, assessment aspect is available. And please keep contact with him for any things. Any questions from Ramadevi?
Sir, good evening, sir. Thank you very much
for
for
inviting me on video also. You reached home or in college?
Sir, I am at college only, sir. Mobile data is not sufficient,
please,
so I couldn't.
Please introduce and ask any questions because you are experienced more than I think 15 years in testing.
Yes, sir. Thank you, sir. So I am actually trained by only Dr. Venkatesh Babu, sir. He only trained me.
Now you are eating. Don't tell all those things.
Yes, sir.
Whenever
Sir,
you have any problem faced during NDT testing.
Sir, no problem, sir. But I've got one clarification, sir. Is there any, for example, if for NDT certification course, only mechanical course they are running, sir, in that they have got 1 or 2 civil application equipment. But is anybody running a specific NDT certification course for civil engineering in specific?
No, I don't think so.
Yes, sir.
No, only for steel structures and steel inspections,
yes,
NDT is available. Actually, there were some attempts for some institutes from Pune to give this certification, but I think it is not continued. SCRC conducts regularly these NDT courses. Maybe they will be useful.
Sir, you can plan once, sir. We can all mobilize many things and we can visit your test house also.
We can conduct a training program, but she wants a certification for certified course. Like for NDT in steel structures or weld testing and all that. It is a certification prescribed certification course which is given by NDT Institute. It's in Chennai.
Yes, sir.
But, we don't have such programs in for NDT in concrete.
Yes, sir. Yes, sir.
Yeah.
But as a reputed company, you can train and certify. That is also valid, sir.
I don't know, but we can certainly train.
Yeah.
We can certainly give the training and.
If you are able to mobilize, we can come and 1 or 2 days we'll plan.
Sure, sir. Sure, sir.
Because a lot of engineers, there's one conference is going on Sudhakar called Morning there.
Okay, sir.
There is a national seminar they are going to conduct by ACEC. If any members are there, 40, 50, I think the STEDRANT company can help because all our engineers are doing different testing.
Yes, sir.
Design, propose everything. You want particularly NDT only, no?
Yes, sir. Then only we can. So we are actually doing some consultancy works. We are putting signatures and giving them reports. But to what extent it is valid, that we don't know, no, sir. If you are having a certificate, then it will be.
See,
much.
you are certifying with a code, the reference of BIS codes of practice.
Yes,
No?
sir. Yes,
If
sir.
you
Yes,
are-
sir.
That you have to mention. See, as per this is the sample given or what sample tested, conducted as per guidelines given by the Bureau of Indian Standards. That the deviation, then it is a problem. That's all.
Yes, sir. That we are doing, but still, I just wish to know: is there, for example, for green building lead auditor like that and all, we have got a certification course.
So any
If there is-
association is there, sir, in India? NDT association?
No.
All India level.
Concrete, we don't have any association.
Okay.
Steel structures, there is one.
Okay.
So, but earlier also, when we were in civil aid, we have been conducting a course on NDT and also the case studies for many of the engineering colleges we have conducted. For example,
Once your lab is NABL, your problem is solved. I think STEDRANT is NABL certified.
Yes,
So whenever NDT test you are doing, all your instruments are calibrated. Even who is going to testing person also cross-check. What, sir?
Yes.
Question, sir?
Yes, correct.
Therefore, you better go for NABL
if you get an
accreditation of
NABL, that is one indirect way of getting the certification.
Yes, sir.
Actually, once you show NABL accredited, they will do instrument wise. You can go with rebound hammer, they will enable accreditation. UPV like that. Whatever
Yes, sir.
instruments you are using, go for enable accreditation immediately. Then you can claim that you are certified, authorized person to do all these things.
Yes, yes.
Your
Because
instrument is
our
calibrated.
lab has got NABL accreditation for most of for all the NDT tests,
Yes, yes, sir.
including the core test, ultrasonic, rebound hammer, everything, thickness gauging, cloud test, most of the tests, whatever we showed.
Madam, even I given a name also, name of the person for NABL.
Yes, sir. We are going to contact them because for the past 1 month we were running for NBA as well as snacks, sir. Day before yesterday, it was
You
over.
can
So
go
now,
with all the NDT instrument, and there is instrument which is NABL actually.
sure, sir. Sure.
Then you can claim the certificate, show the certificate, put the signature. That's all.
Yes, sir. Yes, sir.
See, who is the manager, technical manager, and there is a designation will be there according to NABL guidelines. What, sir?
Yeah, no, authorized authorized signatory will be there.
Yeah.
So they have to put it, and also there on each page they have to put the seal and also the certification number and all that. So once it is done, it becomes authenticated.
So only one question in chat box. Venkat Soy Nag, he's available. Hello, Venkat Soy Nag.
Yes, sir. Yes, sir. Yes, sir.
Please ask the question. Please introduce yourself.
Sorry, sir. This is Venkat. Sir, can we do
You are
the
audible. Please go
core
ahead.
test immediately? Yes, sir. Yes, sir. Can we do the core compressive strength test after pulling out immediately, sir?
See, even to extract a core, it has to be at least concrete should have attained certain age. Otherwise, if it is a very young concrete, what happens is the disturbance during coring can give rise to a lower strength. So usually we don't extract concrete core if the concrete is less than 10 days old. So anything more than 10 days old, then only we extract the core. And immediately after you see, suppose you want the strength at 14 days, you can extract 11 days and then you can do the test. Otherwise, you can extract the core, keep it for 28 days and you can do the test. So depending on what age you want, you can do the test. But for taking the core, we always prefer not less than 10 days.
So even the core samples are taken when the cube results are failed. The cube results are 7 days or 28 days. See, generally they'll wait for 28 days. If the cubes are not given the results, immediately they'll suggest for core cutting. That means 28 means
they want to do some overlapping.
Yeah.
Many times they come and then say we would like to take the core early. So then we take only if the age of concrete is more than 10 days.
Arpita, you have any question? PWD. Arpita. Thank you, sir. Actually, I hope there is no questions. Any questions are there? Mail ID is shared. please contact Dr. M.S. Sudarshan. Sir, thank you once again, sir.
Thank you very much.
Two participation, sparing
Thanks for the opportunity provided.
Yeah, thank you very much. Thank you a lot from on behalf of Center and my own. I'll thank you once again. And I request all the participants to learn many things, construction engineers to learn every day, because otherwise there is the chances of losing information. You must, because you may be a site engineer, you may be a project engineer, you may be different positions. Therefore, learning should not be stopped. Then I'll, Sanat Kumar, any other questions online?
No, sir.
Yeah, I'll thank you once again to all the participants. And also I'll thank Sanat Kumar, the online coordinator, successfully completed phase 1, phase 2. Sir, this is the 26th lecture in the online, sir.
Oh, good.
Sir, Sanat Kumar is the backbone of his online, all these coordinations.
Very
Thank you
nice.
once again to all of you.
Thank you all.
Yeah, we'll close the meeting, sir.
Yeah.
Okay, sir.
Thank you, Rama Devi madam, for joining all the way from Coimbatore. I think your assistant also joined.